Welcome to this fourth lesson in our linear algebra course. Today we will be introducing a new concept, the concept of a subspace. And it ties in very well with what we talked about when defining a vector space. Okay, so definition. I believe this is the second definition, right? So what is a vector subspace? So a vector subspace, or we'll just call it subspace, the vector is quite implicit. So a vector subspace W of a vector space V over the field F is a subset of V satisfying the conditions of a vector space, so satisfying Vs1 through Vs10. Okay, so essentially a subset of V is considered a subspace if it satisfies Vs1 through Vs10. Okay, and we say that W is a subspace of V using this symbol right here. It's very similar to the greater than or smaller than sign, but it's supposed to be a bit more curved here, like exactly like that, more or less. Now what we can now do is notice that some of the properties Vs1 through Vs10 are true for any subset of V. If we go back and see the properties here, right, you could see that some of these obviously are satisfied for any subset. For example, commutativity, right? Commutativity is true because it is independent of the fact that you're dealing with a smaller set of vectors, right? So even if you take a subset of V, Vs3 is always going to be true. The same goes for Vs4, right? There are no conditions on something belonging to V instead of a subset of it. Okay, so Vs4, Vs5, Vs6, Vs7, all of these, as well as Vs8 and Vs9, right? All of these are, Vs8 not really, but Vs10, Vs9, Vs7, Vs6, Vs5, Vs4, and Vs3 obviously have no mention of whether or not a vector has to belong to V and not a subset of it, right? It's true for any subset of V. But the conditions Vs1, Vs2, which are the closure conditions, as well as condition 8, right, which says that the zero vector must belong to the vector space, these have are not necessarily satisfied for any subset of V. Okay, so for a subset to satisfy all of these conditions, right, obviously it has to satisfy not only the ones that are always satisfied for any subset, it also has to satisfy Vs1, Vs2, and Vs8. Okay, so these are the ones that we do have to prove. The other ones are just immediately true because Y is a subset of, W is a subset of V. Oops. Okay, so what we can then do is theorem 1, first theorem, right? W, if W is a subset of V, it is considered a subspace of V if for every y1, y2 belonging to W, and for every alpha belonging to the field F we mentioned here, Vs1 has to be satisfied, so W1 plus W2 must belong to W. Then alpha times W1 must belong to W, and thirdly 0 must belong to W. Okay, Okay, so these are the three conditions that must be met, the only ones that have to be proven, because the other ones are immediately true, because W is a subset of V.